Tamir, you still with us? Because I hear you in about 2 hours.
Yes, I'm here.
Okay, good. So because we would have calculated our turns ratio from earlier, we would have been able now to calculate everything this question required for us. So in recap, whenever you're given a transformer calculation problem, if you're given it in words only, my advice is that you sketch a diagram that looks similar to this. You will always have your primary coil on the left, the secondary coil on the right. Note that the primary coil is the input or the supply, while the secondary coil is the output or the side that uses the voltage. Note that if the primary voltage is larger than the secondary voltage, this is a step down transformer. If the secondary voltage is greater than the primary voltage, it is a step up transformer. The number of turns on the primary coil versus the number of turns on the secondary coil determines the amount of voltage that will be transferred from coil to coil. Note also that a transformer doesn't have any mechanical connection between the primary coil and the secondary coil. It is only an electrical connection, meaning when a voltage is placed into the primary coil of a transformer, it causes a magnetic field to be established within that primary coil that is equal to the amount of turns in that coil as well as the type of core material. That number of turns now is transferred magnetically to the secondary coil, which will accept as much magnetism as is equivalent to the capacity of the amount of coil that is turned on that the amount of windings on the secondary winding. So if the winding based on the amount of windings on the secondary coil, it determines the amount of current or voltage that is transferred to the secondary section. Now, if you memorize the turns ratio formulas and you look at the question and you are able to find or to locate two values that are common, then use them to calculate the turns ratio, and then use the turns ratio to calculate everything else that is missing. To calculate power or to calculate efficiency in a transformer, you will take the input power and you will take the output power divided by the input, and that will give you the value or the percentage of what you call efficiency. Output over input determines. Any questions as we scroll down? We soon get to the end. No questions?
Yes.
Nah, man.
All right, good. Clear on. So as you can see, if we were to add these points up for this entire thing so far, 2 questions in, you see you have so far you would have had, let's go, you had 16 points for labeling that, plus you have another 6 points, that's 22 points. That's off 1 question. Then you move down to this next question, and you have This is what? 9 and 3, that's 12. So that would be 34 points of 2 questions already. All right. Plus 4, that's 36 points already. Okay.
How much is that?
36 of 2 questions. Then we have.
No, I mean all together.
We ain't reached all together yet, Alfonso. I want this thing need to rotate, and I'm in Word. Y'all, I'm sorry, but y'all gotta turn y'all head to the side, like y'all have a problem. But so you also will have labelings to do, and if you check your booklet has a whole 2 pages on what are called circuits, which will be typical circuits that are shown in your BVCSE exam. Now, as you can see, this is a pictorial sketch showing 2 ceiling lamps. One on they're on the same line. However, one is controlled with the wall switch while the other is controlled with the full chain. The source is at the switch. So while you refamiliarize yourself with how to wire, let's go with doing the supply. The supply of this is a 3-wire supply, but they're saying to you you can leave out the ground wire. Okay, so you'll put black. Black is for what? What do you use the black for?
What you use black for?
Yes. What the black wire stand for?
Black is hot, right? Yeah, hot.
Right. So let's write it out now. Black is hot.
I had the answer. You know, you tell me move my call.
No, it ain't. It ain't. Thing I'm in the background one give us our life story, man. We ain't on the run. All right. Black is hot. Brown.
My name is Spence. Get money.
Brown is what?
Brown is neutral.
Neutral. Red is switch feed.
Green is brown.
Green. Brown. Oh shoot, I can't say. And blue.
Blue is traveler.
Traveler. No. All right. So now we started with brown and the white. Now, the brown is easier to wire, so we'll go with the brown first. So when it comes, it gotta go past. It goes past the switch, and because it's 2 lights that require the use of it, we will slice it and connect one, and we'll send the next one on to the next lamp. Now, the only good thing about this, you don't have to worry about silver or brass screws when you're doing this. Only that when you're doing sockets, you gotta make sure you do it tight. So if we have a question with the socket, you'll see. All right. Then now, the black now, we will have to splice the black because it says one is controlled by the switch while the other is controlled by the pull chain. So when the black comes up into the switch box, we are going to splice it. Send one to the switch, and we're going to send the next one up through the pipe pass the first light, then we send it across and we'll connect it to the pull chain. So this is the only type of light that will use black directly to it because it has its own switch. Oh, red. Okay, red. Then now you will take red off the switch and you will connect that to the opposite side. And you would have had 3 points for that. So you already moved up to 39 points already from this simple part of the question. All right. Let's look at the next side to see what else we have here.